Dear friends, before we start this explanation, I want to first say that if you have any related question, please feel free to ask that in the comment section, and we will be most happy to help you with every possible answer. Hello, everyone. Today, we're going to dive into the world of DPDT relays and learn how to connect and use them. DPDT stands for double pole, double throw, and these small but mighty components are crucial for controlling high-power circuits using low-power signals. What is a DPDT relay? A DPDT relay is essentially two separate switches controlled by a single electromagnet. The relay has a coil, which creates an electromagnet when a voltage is applied. It has two independent sets of contacts, known as poles, pole 1 and pole 2. Each pole has three connection points. The common pole contact, pole 1 or pole 2. A normally closed, NC, contact. A normally open, NO, contact. Looking at the relay pinouts, you can easily identify the pins for the coil, pole 1, NC1, NO1, and the second set, pole 2, NC2, and NO2. How the contacts work. The key to a relay is how the contacts switch between the NC and NO positions. State 1. No voltage to the coil, de-energized. When no DC voltage is applied to the coil is de-energized. A spring tension inside the relay keeps the common pole contacts connected to the normally closed NC contacts. In the example diagram, without the coil voltage, we can see that the AC mains current cannot flow through the NC2 contact and the bulb remains shut off. The circuit connected to the NC terminals is the default of state in this situation. State 2. Voltage applied to the coil, energized. Now in our next image we can see that when a DC voltage, matching the relay's coil rating, is applied across the coil terminals, the coil becomes an electromagnet. The electromagnetic attraction pulls the common pole contacts away from the NC terminals and connects them to the normally open NO contacts. In the diagram, the AC mains current now starts flowing through the NO2 contact. The bulb is now able to get the AC supply and turns on as soon as the circuit is switched from the NC path to the NO path. The circuit connected to the NO terminals is the default on state that turns on the bulb when the relay is triggered in this situation. Once the coil voltage is removed, by opening the switch in the diagram, the spring tension immediately pulls the contacts back to the NC position, turning the NO circuit off and the NC circuit back on. Now, if the bulb and mains AC connections were wired with the NC contacts instead of the NO contacts, then the outcome would have been just the opposite. Practical application. Controlling AC with DC. The operations as depicted above clearly show a practical application. The control circuit. This is the low-voltage DC side connected to the coil and the switch. You use a low-power signal, like from an Arduino, or a simple switch as shown, to turn the electromagnet on or off. The load circuit. This is the high-power AC side connected to the pole, NC, and NO contacts. The physical contact switching controls the main load, in this case, a light bulb, entirely isolated from the low-voltage control circuit. This is why relays are vital. They allow a safe, low-power control signal to switch a potentially dangerous, high-power circuit. So friends, that's the basics of how a DPDT relay works and how its contacts are connected. If you have any doubts or questions, please feel free to ask them in the comment box to get quick replies from me. Thank you very much for being with me. Until next time.